Hello students. So after we have talked about some of the different kinds of gauges, a next thing that we might be doing is we might be designing gauges of our own. And so if we're going to do that, we need to understand how to tolerance the gauges. Because at some point somebody's got to build this gauge for us, or maybe we need to be able to go buy a standard item off the shelf for it, depending on what it is. And so we have to know how to tolerance them, and that's not completely obvious. And so there are some rules of thumb that we start with, and then once we've done that, it turns out there are some things called gauge classes, and we can use those to help us sometimes to figure out what we ought to do for tolerancing. So let's go ahead and get started. Okay, so when we go to buy a gauge, we typically will try to get the tolerances to be in one of these three groups. So for a working gauge, that is a gauge that we're going to use on the shop floor every day. It's one that the operator is just going to pull out of the toolbox and check real quick on a lot of parts just to see if they are making good parts so they don't send a lot of bad parts down the line. We would use 10% of the tolerance of the part for those working gauges. Now, an inspection gauge is often a gauge that we would keep in the metrology room, and we would bring it out once per day to check the working gauge to make sure that the working gauge hasn't worn to be out of tolerance. And so that inspection gauge, we might also use it more commonly, say we're pulling some percentage of the parts and taking them into the inspection room. We could use it there for those parts, and that's sort of a better check. So for that, we would use 5% of the part tolerance, and then the master gauge. So the master gauge is going to be one that's kept in the metrology room, and it's probably going to be kept in a really nice case in a temperature and humidity controlled environment. And it's one that we're going to pull out really rarely just to check and make sure that our inspection gauges are still good. The master gauge is the one that we're going to get sent off to some house to be calibrated and to confirm that it is still within compliance, because all of our parts will be based on the values for that master gauge. So 10%, 5%, and 1% of the part tolerance is kind of what we're thinking. Now, one thing to be aware of is a common mistake is if we have 1 1/4 inches plus or minus 5 thousandths, that is a tolerance range of 10 thousandths. You have plus 5 and minus 5, so the total range is 10 thousandths of an inch. So it turns out that for a lot of standard items, so ring gauges, step gauges, some length gauges, pin gauges, some things like this, there are some standard classes of gauges that are produced. And so instead of having to go and work with a precision grinding company and saying, okay, I need this thing and I need it to have 5% of my part tolerance is the tolerance that I'm going to give you for making this part. A lot of companies will have these sets of gauges that you can buy, and they will come based on a class. So class Z is often used as a working gauge. Class Y could be a working or an inspection, depending on what your company chooses to do. Often it depends on the consequence of the parts that you have. Class X is some master, but more often closed tolerance inspection and some working gauges. And then XX is a master gauge, or maybe a final, close tolerance inspection. So these are sets that you can just buy. You go buy a Class X set of gauge pins, and then you have this full set of gauge pins to use. So how do we decide which one of these we need? What we do is we do this rule of thumb first. We calculate our 10%, 5%, or 1%, and then we go to a chart and we see which gauge class is as tight as what we calculated or a little bit tighter. We don't want it to be worse. We want it to be the same tolerance or a tighter tolerance, something that is less than we use. So let's practice that a little bit here on this screen. So the way that this works is you have to look at the dimension because the gauge classes change by dimension. You can see that if your part is between 10 thousandths and 0.825 inches in diameter or length, a double X gauge is 20 millionths. But if you have a really big part between 9 and 12 inches, a double X is 100 millionths. And so the tolerance becomes looser as the part becomes bigger. And so you have to find on this list, you use the first two columns to find where your dimension is, and then you go through and you compare the class Z, class Y, class X, and class double X to see which of those classes of gauge you should be using. So let's try that a little bit. So here we go. We're going to take this first one. There we go. And we're going to make the first one be black. So the first row is going to be black. And it says 1.75 is our regular tolerance. So 1.75 is here, right? It's between 1.5 and 2.5. So then we're going to think about this and we're going to say, okay, this is plus or minus 5 thousandths of an inch. That gives us a tolerance band of 10 thousandths. We have plus 5 and minus 5. So that gives us 10 thousandths. So our working gauge at 10% is going to be 0.001. 1 thousandths of an inch. Our inspection gauge is going to be half that, 0.0005. And our master gauge is going to be 1% of this number, so that is 0.0001. Okay, so now what we do is we go up and we start looking along this row to see if there is a gauge that is tighter, slightly tighter than our value. So our working gauge was 0.001, and we look up here, so we have 1 thousandths, and the smallest that we have here is 160 millionths. Okay, so this is a considerably tighter tolerance than we need for our working gauge, and so we would use a class Z. So we'll write that down right there, class Z. Now our inspection gauge was 500 millionths or 5/10,000ths of an inch, and when we look up here we see this is 160 millionths. Well, 160 millionths is still a tighter tolerance than our 500 millionths, and so here again we would use a class Z. Now our master gauge needs to be 1/10,000ths, or sometimes it's easier to speak of that as 100 millionths. And so we go up to this line and we say, well, that's 160 millionths, so that's a bigger tolerance, that won't work. 120 millionths, that is a bigger tolerance, that won't work. This one is 80 millionths, and so that one is a tighter tolerance than we calculated, and so we're going to use a class X for this master gauge. All right, we'll change to blue, and we will look at the second row. So this is 1.75 again, so it uses the same row. And we can see that our tolerance range here is 0.002. We have plus 1 and minus 1, so the full range is 2 thousandths. So our working gauge is going to be 10% of that, so that is 200 millionths. Our inspection gauge is going to be 5% of that, or half of our working gauge, so that is 0.0001. 100 millionths, or 1/10,000ths, same number. And then our master gauge is going to be 0.00002. That's 20 millionths. Okay, that's getting small. So we'll start with this number right here. So we have 200 millionths. We look at this line because remember it was between 1.5 and 2.5. And so we have 200 millionths. This is 160 millionths. And so we see that a class Z will work just fine for our working gauge because 160 is less than 200. Now we look at our inspection gauge, and it is 100 millionths. Look up here, 160 millionths. No, 120. No, that's too big. 80 millionths. Okay, so our inspection gauge can be a class X because 80 millionths is tighter than our 100 millionths. And then we need this at 20 millionths. And what we see is 160, 120, 80, 40 millionths. So there is nothing up here that will work. And so what that means is that we are going to have to use a custom gauge. We're going to have to have somebody build us a custom gauge. We can't use one of these pre-built gauges for this. All right, for our last example here, we'll make this one in red. Oops. There's a little thing down there, it turns out. Okay, so 6.6 inches. Let's see, that's bigger than 4.5. Oh, but it's bigger than 6.5 as well. So it'll be right here between 6.5 and 9.01. That's where we find our 6.6. And our total tolerance range is +5 and -5, so that is 0.010 inches. So 10% of that is 0.001. 5% is 0.0005. And 1% is 0.0001. All right. So we start out here and we have 1/1000th of an inch. We look on this line, and our class X is 320 millionths, or 3/10,000ths of an inch, 3.2 10,000ths if you want to do that way. So a class Z is 3 times tighter than what we need, but that is what we would use. Okay, because that just means that the gauge is more accurate than we have to have it. We look at the next one, and the next one is 5/10,000ths, or 500 millionths. And when we look at this line again, oh yeah, a Z is 320 millionths, and we need 500. So this is still tighter. So a class Z would be great. And then we look at this, and this is 1/10,000ths, or in this case it's easier to think of it as 100 millionths. So we have 300 millionths, no. 240 millionths, no. 160 millionths, no. 80 millionths. Okay, so 80 millionths, a class double X is the only gauge class that is tighter than our rule of thumb. And so we could use a class double X for our gauge. Okay, so what we're going to do next in the next video is we're going to take this and say, okay, we have an understanding, maybe we're making a gauge and there is not just a standard gauge that you can buy. So we're not going to be, sometimes we can't use these gauge classes because we're just making something on our own. And if that is the case, how do we apply that tolerance? And so that's what we'll do in the next video. See you there.